Okay, so a pleasant morning to all of you. For today, I will be discussing with you all about the causes of climate change. But before we proceed on our lesson proper, I just wanted to share with you first our lesson overview for today. Okay, so let's proceed. Our first topic would be all about the climate change caused by the natural events. So this includes the feedback mechanisms, the plate tectonics and mountain building, the variation in the Earth's orbit, the variation in the solar output, and at the same time the atmospheric particles. We'll be also discussing the climate change caused by the human anthropogenic activities, which includes the aerosols injected into the lower atmosphere, the increasing levels of greenhouse gases, and the land use changes. Okay, so let us now light the bulb as I present to you the topic for today. So as Earth's inhabitants, it is our role and responsibility to understand the causes of climate change so that we can take preventative action to minimize it. So if we are properly oriented about the causes of climate change, then we can do some sort of measures or practice measures that would at least lessen the threat of the climate change. So as early as now, we must be able to be oriented, because I do believe that the small acts that we can do could greatly contribute our Mother Earth, or for us not to experience the danger of the climate change. The causes of climate change can be categorized into two. Okay, so number one, this is the climate change caused by the natural events. Maybe you are thinking that the climate change is only caused by the human-induced activities, but you're wrong, since there are also tendencies wherein natural events or natural means or phenomena could also trigger climate change. Number two is the climate change caused by the human anthropogenic activities. So this is very obvious. Later on, we will be further discussing what are these causes. Okay. Why does the Earth climate change? Okay, so you can pause this video and think kung bakit nga ba why is it that the change is like that the climate is changing. So you can pause the video for a while and think over it. Okay. So there are three external causes of climate change. Number one is the changes in the incoming solar radiation. Number two is the changes in the composition of the atmosphere. And number three is the changes in the Earth's surface. This natural phenomena could also cause climate to change by all these three mechanisms: the incoming solar radiation, the composition of the atmosphere, and the Earth's surface. So I just wanted to clarify with you right now that the incoming solar radiation can be categorized via natural means, and these two, which is the composition of the atmosphere and the Earth's surface, can be categorized into human-induced activities, otherwise known as anthropogenic activities. Later on, we'll further discuss that. There are two internal causes. If a while ago I discussed with you the external causes, for now I will present to you the internal causes of climate change. Okay, so number one, the changes in the circulation patterns of the ocean. And number two is the changes in the composition of the atmosphere. Okay, so I want you to think over this. I got this from the book of the Essentials of Meteorology, An Invitation to the Atmosphere, wherein it says that no climatic element within the system is so isolated from the others. So you may think over it and post the video. Okay, so I think climate change is so broad, okay? So it cannot be you cannot polarize the idea that the climate change is just caused by the human activities. So there are also certain factors like the natural phenomenon or the what is happening inside and outside the earth that could cause climate to change. So as early as now, I want you to be oriented that climate change is not just caused by the human activities. There are also tendencies wherein other factors could also trigger climate to change. Okay, so let's now dig deeper on the climate change caused by the natural events or natural phenomena. Number one is the feedback mechanisms. So maybe some of you are already aware of the feedback mechanisms, but in here, in climate change, a feedback mechanism is something that speeds up or slows down a warming trend. So as you can see in the figure, so it is something that speeds up and something that slows down a warming trend. Okay, so as it's a positive feedback accelerates a temperature rise, whereas a negative feedback slows it down. How do these feedback mechanisms changes the climate? Okay, so what I said earlier, there are two types of feedback, which is the positive and the negative feedback. For now, we'll be giving examples on the positive feedback mechanism, which number one is about the removal of the ice high albedo. Okay, so we are already aware of the albedo since some of the reporters already discussed all about the albedo. So once the Arctic, Greenland, and Antarctic ice sheets melt, water absorbs more heat. Okay, so because ice has a high albedo, it reflects 84 to 90% of incoming solar radiation. But once we remove our icy protective shield, water reflects as low as 6% of solar radiation. So see the difference. Okay, so if we have, ice sheets in the surface of the earth, so it could cause at least the tendency is that we will have a high albedo effect. Okay, so 84 to 90% of reflection or the solar radiation will be reflected back to the outer space, unlike if it melts and then we have just water, it only reflects just 6% of the solar radiation. Okay. So as you can see here in the figure that I'm showing you right now, on a warming planet, the snow albedo positive feedback would enhance the warming. Okay. In polar regions, snow reflects much of the sun's energy back to the space. Okay, here in the figure A. In figure B, if the air temperature were to gradually increase, some of the snow would melt. Less sunlight would be reflected and more sunlight would reach the ground, warming it more quickly. Okay, so if there is no ice or minimal ice sheets only covering the surface, then there will be tendency that we will experience warming, since it is not that much reflected back to the outer space. So the warm surface would enhance the snow melt, which in turn would accelerate the rise temperature. So as you can see here in figure C, it says here that it has a very low surface albedo, much higher absorption of sunlight, which means that the surface warming is enhanced. Okay, let's proceed with the sea level rise as a positive feedback example. So as the planet warms, ocean waters expand. Okay, so rising sea levels hit coastal cities the hardest. So that's very obvious. But another result will trigger further glacier calving. So if you increase water volume, this could cause further chunks of the ice to outpour into the ocean. So this is quite related to the albedo a while ago, wherein if you have, increasing level of water, the tendency is that the ice in the polar region would melt due to increasing level of water, and then there would be low albedo effect. So it would cause, warming of the Earth's surface, or warming in the hemisphere in general. Another example of a positive feedback is the rainforest drought and loss. So we all know that once we remove trees, there would be tendencies for desertification, or otherwise known as drought. Okay, so temperatures are projected to rise 2 to 6% by 2100s. As a result of the warmer climate, this will result in larger evaporation losses. So imagine what would it be without, if the evaporation will decrease. Okay, so despite the possibility of more rainfall, unpredictable weather may result in less soil moisture. So less soil moisture, meaning there would be tendencies for a drought due to a warmer means, and of course it would affect our daily necessity, or the crops that we need as our daily or basic necessity. Okay, so let's proceed now on the negative feedback mechanism example, which includes the increased cloudiness reflects more incoming solar radiation. So we already discussed this. You already discussed this during your previous lesson, or during the previous report. So I think it does not need for me to elaborate this idea that much. But I think I need to give a short insight about this. So as ice sheets melt, this could increase cloudiness with more water vapor in the atmosphere, because cloud reflects 1/3 of the incoming radiation. So there would be less heat absorption on the Earth's surface. So see how does the cloud benefit us from not experiencing too much heat, okay, since it reflects the incoming solar radiation. Next example of a negative feedback mechanism is the chemical weathering as a carbon dioxide sink. So with more carbon dioxide and water in the atmosphere, it increases the carbonic acid, which is just the combination of CO2 and water. Okay, so chemical weathering in rocks is a sink for atmospheric carbon dioxide. Thus, it weakens the greenhouse effect and leads to cooling. So that's very self-explanatory. I think you already understand this concept. Okay, so in summary, the Earth's atmosphere system has a number of checks called feedback mechanisms that help it counteract the tendencies of climate change. Okay, so let's proceed on the next cause of climate change via natural means, which is the plate tectonics and mountain building. Okay, so one of the external cause of climate change is the change in the surface of the Earth. Okay, so we already know that. So during the geologic past, the Earth's surface has undergone extensive modifications. So as you can see in the figure here in the picture here that I presented, so due to modifications such as volcanic eruptions, earthquake from faults, or moving seafloor spreading, then there is indeed extensive modification in the past and up to this very moment. So this motion is explained in the widely accepted theory of plate tectonics. So I hope right now you already know what a plate tectonic is, what the theory of plate tectonic is. So it's just, a theory wherein we started from a big landmass called Pangaea, and then as we and they believe, I think it was Wegener was the one who proposed this, and uh, as the time passed by, the the land mass is increasing, is moving or spreading, circular spreading, and then we come up with what we have right now, which are the continents. So I hope you had already the idea about the theory of plate tectonics. So some scientists speculate that climatic change taking place over millions of years might be related to plate movements and hence to the amount of CO2 in the air. Okay? So how do these plate tectonics and mountain building changes the climate? Bakit nga ba? Okay, so during the times of rapid movement, an increase in volcanic activity vents large quantities of CO2 was released into the atmosphere, which enhances the atmospheric greenhouse effect, causing global temperature to rise. We cannot deny the fact that during the past there are a lot of volcanic eruptions, earthquakes. So as you can see in the figure, this is a eruption. So there are also time scenarios or scenes wherein the movement decreases or there is less volcanic activity, means less CO2 is spewed into the atmosphere, and the scientists observe that during this less movement, a reduction in CO2 levels weakens the greenhouse effect, which in turn causes global temperature to drop. So see how does the plate tectonics along mountain buildings and different volcanic activities had a great factor in the climate that we are experiencing. Okay, so the accumulation of ice and snow over portions of the continents may promote also additional cooling by reflecting more sunlight back to the space. We all know that as the latitude, as we go to high latitude, or specifically the areas in the polar regions, they're already experiencing cool climate, since the sun is not that much directly, the sun's strength or the sun's energy or solar radiation does not much it's not heat directly the polar region or the areas in the northern hemisphere and the southern hemisphere. That's why they're experiencing a cool temperature or accumulation of ice. So the tendency is that this could be correlated again with the albedo that we discussed before, to reflect the incoming solar energy back to the space. Okay, so this will cause generally net cooling or cooling in the area. Okay, I think this cooling or the albedo effect that's happening in the polar region has also impact in the temperature of the entire Earth. Okay. So mountain building that occur when two continental plates collide can have a marked influence on global circulation patterns and hence on the climate of the entire hemisphere. Okay, so if there is a mountain, of course, the air temperature is quite, if there is a formation of the mountains, the air temperature will be also affected. The flow of the air temperature will also be affected. Now, on the third cause of climate change via natural events, which includes the variations in the Earth's orbit. So the three changes in the Earth's orbit around the Sun, which includes eccentricity, axial tilt, and precession, are collectively called the Milankovitch cycles. So as you can see here in the image, the moving image, the three Milankovitch cycle. So the first is the change in the axial precession or the wobble in a 26-year cycle. The next image is the change in the eccentricity or orbit shape in a 100-year cycle. The next one is the change in obliquity or tilt in a 41,000 year cycle. Okay, so according to Milankovitch theory, these three cycles combine to affect the amount of solar heat that reaches the Earth's surface and subsequently influences climatic patterns, including periods of glaciation and ice ages. So I think you know this already. Okay, sorry, the slide has been repeated. Okay, so it says here that the time period between these changes can be tens of thousands of years precessions and axial tilt, or more than hundreds of thousands of years eccentricity, which I already said a while ago. So the Earth orbit around the Sun is an ellipse or an oval shape, but it isn't always the same shape of ellipse. Okay, so sometimes it is almost circular, just like what is presented here in the figure, and the Earth stays approximately the same distance from the Sun throughout its orbit. At other times naman, the ellipse is more pronounced, okay? So that there are tendencies wherein the Earths move closer and move further away from the Sun in its orbit. So how do these variations in the Earth's orbit changes the climate? Okay. So, when the Earth is closer to the Sun, our climate is warmer, and this cycle also affects the length of the seasons. So, the measure of shape's deviation from being a circle in the case of the Earth's orbit is called the eccentricity. In the case of obliquity naman, or the tilt in the axis of the Earth, which is called the obliquity, this angle changes with time and over about 41,000 years. It moves from 21 degree to 24 degree and back again. So when the angle po increases, the summer becomes warmer and the winter becomes colder. In the case of precession, the Earth wobble on its axis, much like a spinning top that is slowing down. So this is called precession and caused by gravitational pull of the Moon and the Sun upon the Earth. So this means that the North Pole changes where it points to in the sky. Okay. So currently, the Earth's axis point at Polaris, the North Star, but over thousands of years, the axis moves around in a circle and points at different parts of the sky. It impacts on the seasonal contrast between hemisphere and the timing of the seasons. So I just hope you already correlated how this Milankovitch theory really affect, or how this Milankovitch theory is considered as a cause of climate change. So in summary, the Milankovitch cycles that combine to produce the variations in the solar radiation received at the Earth's surface include the changes in shape, which is eccentricity of the Earth's orbit around the Sun, about the Sun, precession of the Earth's axis of rotation or wobbling, the changes in tilt or obliquity of the Earth's axis. Let's proceed now to our fourth cause of climate change via natural means, which is the variation in the solar output. Okay, so almost all of the energy that affects the climate on Earth originates from the Sun. So the Sun's energy passes through the space until it hits the Earth's atmosphere. Okay, so only some of the energy, as you can see here in the figure, only some of the energy intercepted at the top of the atmosphere passes through the Earth's surface. Okay, so as you can see here in the figure, I think it's about 48% absorbed at the surface. Some of it is reflected back into the space, and some is absorbed by the atmosphere. Okay. So how do these variations in the solar output, or let's simplify it in a term, strength of the Sun via, I think, brightness or solar output, changes the climate? Okay, so the energy output of the sun is not constant, so it varies over time, and this has an impact on our climate change. Honestly speaking, the study on the variations of these variation in the solar output or solar energy as a factor that changes the climate is not yet that much strong, or not yet that much as a foundation, or not yet hindi gaano pang malakas na facts, since it's very hard to measure still the strength we are receiving from the sun. Okay, and the concept between the earth and the concept between the sun, the strength of the sun as a factor that could change the climate is still not yet fully studied by the researchers, due to, it's very hard to study this kind of scope or this kind of, top concept. Okay, but as early as now, they already saying that indeed the strength that we receive from the sun has something to do with climate change. Okay, the last one, the natural events. The atmospheric particles is considered also as the cause of climate change. So it says here that microscopic liquid and solid particles, otherwise known as the aerosols, which is already introduced in the previous lessons that we have in our meteorology, it entered the atmosphere from both human-induced and natural sources and this can have also an effect on the climate. So in this case, we will only examine those particles that enters the earth through natural means. Okay, so how do these atmospheric particles or aerosols changes the climate? So as particles near the surface are produced through wildfires, there are tendencies for it to release, tiny smoke particles and thus storm. Okay? During the smoldering volcanoes naman, there are also tendencies wherein it will release a sulfur-rich aerosols. In the sea, or in the case of the phytoplankton, wherein it produces a sulfur dioxide sulfate aerosols via different conversion methods or natural processes, then it also has something to do with the climate change. So these wildfires, smoldering volcano, and phytoplankton, the particles they release cool the surface by preventing sunlight from reaching the surface. So we all know that aerosols also has the capacity to reflect back the energy, the solar radiation coming from the sun. So in this case, if it is reflected back to the space, then we will experience at least a cooling. Okay. So it also says here that volcanic eruption can have a definitive impact on the climate. So let's be localized by giving you our very own volcano, which is the Mount Pinatubo eruption. So this was retrieved from the WordPress and the Wired. So as you can see, as you can see during the eruption of the Mount Pinatubo, it released a lot of sulfur gases. So based on what I read on the articles, this caused a global decrease in temperature, not just in the Philippines but in the entire world. Okay, so as you can see, it is indeed a huge volcanic eruption. It's not only changes the temperature within the area, but it also affects the earth. I'm not that much sure with the percentage of the global temperature decrease, but I could also provide the percentage on the description of my report so that you will have the idea. Okay, so that's Mount Pinatubo. So let's dig deeper this time on the climate change caused by the human anthropogenic activities. So if a while ago I discussed to you the causes of climate change via natural means, this time let's proceed on the human anthropogenic activities. So to name the number one is the aerosols injected into the lower atmosphere. So I think this is very much familiar with you since you are also a part of this, you are also contributing for this. So to name the few, human-induced sources includes the emission from factories, autos, trucks, aircraft, power plants, home furnaces, and fireplaces. So imagine, take a look of the image. So these activities or the combustion of the autos and trucks is releasing a lot of sulfate and nitrate, which has something to do with our climate change or with the climate. Okay, so I think it's partly discussed that by asking this, how do these aerosols changes the climate? So some particles such as sulfate and nitrates, as what I said earlier, mainly reflect in the coming sunlight, whereas others such as soot readily absorb sunlight. So what does this mean? So many of the particles that reduce the amount of sunlight reaching the Earth's surface tend to cause a net cooling of the surface air during the day. Okay, so in summary, sulfate aerosols reflect incoming sunlight which tend to lower the Earth's atmosphere. Sulfate aerosols may also modify clouds by increasing their reflectivity. So let's proceed on number 2, the increasing levels of greenhouse gases. So I think it's very much familiar with you since I think we already met this concept way back when we were in high school and during previous reporting in the subject. So greenhouse gases include carbon dioxide, methane, and water vapor. So water vapor is most abundant greenhouse gas in the atmosphere. So take note of that. But it stays in the atmosphere for a much shorter period of time, just a few days. Okay, while CH4 stays in the atmosphere for about 9 years until it is removed via oxidation into CO2 and the water. So this oxidation and CO2 and water, we already discussed this during our early SEM in college. Okay, so CO2 stays in the atmosphere much longer, from years to centuries, contributing to longer periods of warming. Okay, so these gases trap solar radiation in the Earth's atmosphere, making the climate warmer. Okay, another anthropogenic activities that cause climate change is the land use changes, or is otherwise known as modification, I think. Modification of the Earth's surface. So taking place right now could potentially be influencing the immediate climate of certain regions. So see in these pictures how we people modify the Earth's surface or our land. So this photo is not mine. Okay, so let's clarify this by asking, how do these changes in the land use changes the climate? Okay, so it says here that the certification or I said a while ago that the certification happens because of the deforestation aside from drought. Okay, so the certification amplifies global warming. So that's very obvious through the release of CO2 because of the decrease in the vegetation cover. Okay. So a decrease in vegetation cover via deforestation, for example, tends to increase local albedo, leading to surface cooling. Albedo refers again as to how much light a surface reflects rather than absorbs. Okay, hope that is very much clear with you. So generally, dark surface have a low albedo and light surface have a high albedo. So ice with snow has a high albedo and reflects around 90%, as well as said earlier, of incoming solar radiation. So land cover with dark colored vegetation is likely to have a low albedo and will absorb most of the radiation. Okay, so ends my the class for today. So I already presented to you the causes of climate change via natural means and via human anthropogenic activities. But before I will end this class, I wanted to share with you this quote from President Obama. No challenge poses a greater threat to no challenges poses a greater threat to the future generation than climate change. Okay? As early as now, since you are already oriented with the different causes of climate change, as early as now, it's important for you as a human being and as a beneficiary of our Earth to at least do certain actions that would mitigate the effect of climate change. It is always important to note that what we can do, small or big, can have a large impact in our society, especially our Mother Earth. So since you are already oriented, I think you can do certain actions, small actions, even at your homes, that will at least contribute for the next generation, for them to still experience the beauty of our nature, so that for them to experience the beauty of our nature. Okay, so I think so that ends my report. Thank you very much. If you have any question, feel free to message me via my official Gmail account, frankjosephtisoy54@gmail.com, or via my phone number, which is presented on the screen right now. And I just wanted to emphasize that this presentation template was created by SlidesGo, including icons by Flaticon and infographics and images by FreePink. Once again, thank you very much and good morning. God bless and happy holidays.